Hello everyone. We have discussed how to create the geometry. Our next session is how to apply the supports. So basically when we are talking about the supports, it is necessary to understand the basic concept of the supports. So basically we have three type of the supports. First is the fixed supports. So a fixed support is the most resist type of the support oblique connection. It constrains the member in all translation and rotation. It means cannot move oblique rotate in any other directions. Suppose this is my example and I am applying a force, a lateral force on this pole, so it will not move because it is fixed from the base and cannot the rotate. It means the degree of freedom is 0 and give the value of fx, fy, fz and moment mx, my, mz. This is your fixed support. So here the example of the fixed support would be a pole, a oblique column in a concrete. So basically pole oblique column cannot twist, rotate, oblique shift. So it is basically restricted in all its movement at this connections. Widely used the supports for a cantilever, foundations parts. In the foundations we consider that a supports is a part that is situated, it means transfer the load of the substructure to the foundations. So it is the mediator part of the substructure and foundations, that is your supports. This is your symbols. How can we represent the fixed supports? The second one is the pin support. A pin support is a very common type of the supports and it is most commonly compared to hinge in civil engineering. Like a hinge, a pin support allow the rotation to occur but no translations. It means when we are applying a force, a beams, suppose I am taking a scale on my hand and apply a gravitational UDL force on the scale. When you will apply the force, you will see my scale will be deflect at the bottom of the sides. At the ends I have the zero moment and at the midpoints I have the maximum moment. It means allow the rotation but shifting is not possible. It means resist the horizontal and vertical forces. Suppose if you are applying the x direction forces, give the reaction in the x. Suppose applying the y as z, they give the reaction y and z. But moment is 0. It means the degree of freedom is 3. And mx, my, mz is 0. Basically, the application of the pin support can be used in the trusses. So this is my image file. Here you can see this is my pin support. I am considering pin support. It means rotations about this point is allowed, but shifting is not possible. And this is my symbol of the pin support. Third support is my roller support. So basically what is the roller support? Roller support can resist a vertical force but not a horizontal force. A roller support oblique connection is free to move horizontal as this is nothing constrained it. It means a, a rotation a roller support is a support where you have only the one reactions. Okay, where you are applying a force, then it will give a one reactions. Either rotation oblique moment can be possible in the roller supports. A sliding door is a good example of the roller supports, and basically it is used in the bridges. So this is a roller support. When the force is coming on this particular girder, then it will shifting in this directions. Okay, so these are the three type of the supports. Now we will learn how can we apply the supports to my object by the help of the ETAP software. So in the starting, I'm just taking this is my banquet hall. So I will explain to apply the support by the help of this project. So this is my grill lines and metric. Okay, 5.4 and 2.7. Okay, so this is number of grid line 2 and 2. We have discussed the grid spacing in the previous sections in a detail. So here I'm taking my live project, and this is spacing 5.4 and this is of 2.7 and number of stories 1. Select the templates. This is my grid only options I will use each and every time, and click on OK. Now this is my grid lines A and B and 1 and 2. Now I have created the framing plan. Okay, and now draw the columns. So click on the columns tools and set the properties from the lower left, and this is my concrete beam. Suppose this is my property of the columns, and I have the columns at the corners. So after that, for applying the supports, you can go to the base by the help of this 2 arrow key. So click on the down arrow key and select the base and make a selection box around the object. So here you can see all the joints are selected. After that, go to the assign joint and restraint option. In this options, I have different type of the restraints. So first one is the fix option. When you will click here, you can see the translation and rotations all will active. It means degree of freedom is 0, and I have all the values. When I will use the second option, this is my pin support. So I am saying rotation about the X. It means mx, my, mz is 0 and fx, fi, fz will be active. When I will use the ruler, it means it give a one force values where we are applying a force. Suppose I am applying the force in the Z, then it will give the vertical value of the Z, and all the values 0. And last one is my pin support, where I don't have any other reaction and the moments. So first, here I am using the first one options, and click on apply. Here you can see the arrow of this support in the 3D views. When I will click the apply, the arrow change from the pin to fixed support. Now suppose if I am selecting again all the 4 nodes around the object, and suppose I am click on the pin support option and apply, then you can see I have the pin support symbol in the 3D view. Suppose similarly, if I am selecting again all the nodes and click on the roller options and apply, so this is my roller symbol. Similarly, again select all the joints and click on the pin and apply, then I have no supports at the particular joints. So these are the commonly 4 type of the supports you can apply your structures. So in my case, I am selecting all the joints and applying the fixed support. So this is the process to apply the supports in the E tab.